Okay, so good evening, everyone. So today we'll start the new module, which is the electrostatics. In this chapter, we'll see like the quantization of charge. Then we'll see the Coulomb's law. By this, we'll derive the unit of charge. Then we'll see electric field due to a point charge, electric field due to uniformly charged ring. These two are from electric field. Then we'll see the electric line of force, electric dipole, and the last will be the Gauss theorem and the application of Gauss theorem. Okay, so let's start with the electrostatics. So if we say electrostatics, what do you mean? Electrostatics is the branch of physics which deals with static electricity. Okay, a branch of physics which deals with what? Static electricity. Okay, static electricity, and the static electricity is totally depends on what? Charge. And you all know this in the previous classes. Charges are two types. One is positive charge and the second one is negative charge. If we put the two positive charge, they will repel to each other, and if we put the one positive and one negative charge, they will attract to each other. Okay, so these are the basics, right? So now we'll just go for the quantization of charge. Fine, quantization of charge. So that's heading quantization of charge. So the fact is all the charges are always some integral of multiplication of elementary charge. What does it means? What does it mean? See, here elementary charge means the charge of electron. Charge of electron. Right? In atom, this is the nucleus, this is the positive charge particle, and these are the electrons, right? In the charge of electron is what? Minus 1.6 into 10 to the power minus 19 coulomb, right? This is the elementary charge, and as per the quantization of charge, all the charges that are observable, all the charges that are observable are some integral of multiplication of elementary charge. Means if we consider the charge q, the q charge will be some integral multiplication of the charge e, which is electron charge, right? And the n will be 1 2 3 dot dot dot, right? So we can say q is equals to plus minus of n of e, charges of electron. So this is known as the quantization of charge. Fine, fine, fine. So we can say that q is equals to 2E. Right, this is absolutely correct. But if we say Q is equals to 5.7E, this will be wrong, because we cannot represent by the decimal value of the integral multiplication of the elementary charge, right? We will have to put the integer value of the charge, right? So n is 1, 2, 3, dot dot dot, however it is, right? We cannot say Q is equals to root 2 of E, right? This is not possible. Q is equals to let's say minus 550.97 E. Okay, this is also not possible, right? Right. So this is the important, that all the charges are always some integral multiplication of elementary charges. All the charges will be some integral multiplication of the charges of electron, which is 1.6 into 10 to the power minus 19 coulomb. Fine. Fine. So now we know that the SI unit of charge is Coulomb, right? Coulomb. So how can we say it Coulomb, right? Because as per the Coulomb's law, first scientist Coulomb had discovered the forces between the two charges. As per the Coulomb's law, as per his name, we know that the charge, that the SI unit of the charge is Coulomb, right? So now we'll see the Coulomb's law. Coulomb's law. Coulomb's law, right? So the statement will be statement will be the electrostatic force of interaction. Okay, so let me write first, then we'll discuss about this. So the statement is the electrostatic force of interaction between 2-point electric charge is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. See. This is charge Q1 and this is charge Q2, right? These two are placed at a distance of R. Fine. The Q1 is at okay. So the Q1, okay. So the force of Q1 is F and the force of Q2 is F, right? Then as per Coulomb's law, the force will be proportional to Q1 into Q2. See, the charge is directly proportional to the product of the charges, and the inversely proportional to the square of their distance, Okay, so this is derived by the law of Coulomb's law. Fine. So if we remove the proportional sign, then we can write Q1 Q2 by R square, but we have to put some constant is K. Okay, so this constant value is 1 by 4 pi epsilon naught. Okay, here epsilon is known as the permittivity. It is depends on the where the charges are placed. Okay, right? Epsilon is known as permittivity If the two charges are placed in the medium which is vacuum, then we'll write the epsilon naught, which is permittivity at vacuum. Okay, permittivity at vacuum. Fine. If the permittivity at vacuum, then the constant K will be 1 by 4 pi epsilon naught, which will be equals to 9 into 10 to the power 9 Newton meter square by Coulomb to the power minus 2. Okay. Okay. So just know this value, because in the numerical maybe this value is required. Okay. So we can now say the Coulomb's law is, the derivation of Coulomb's law is F is equals to 1 by 4 pi epsilon Q1 Q2 by R. Okay. So this is known as the Coulomb's law. Right. So now the we can say the SI unit of charge. SI unit of charge is what? Coulomb. Coulomb. Okay. And the CGS unit of charge is ESU. Okay. Or state current. Okay. Fine. So now the next topic is electric field. So what is the electric field? Like there is a charge Q. Q. Okay. So in the area besides the charge Q, if we put another charge which is Q1, then the Q1 will experience a force by Q. This is known as the electric field. Means there is a region of space around a charge. There is a region like this region of a of charge, this charge, Q charge, where if we put another charge, this charge will experience a force. So this region is known as the electric field. Fine. So if we write the definition, then the we can write that there is a region of space around a charge or a system of charge where within this region another charged particle experience electrostatic force. So this region is known as electric field. Okay. Electric. Okay. So now let's find out the electric field due to a charge. Fine. So let's find out electric field due to a point charge. Okay, electric field due to a point charge. Okay, so now let me draw first, then we'll consider a point charge which is Q, at the origin of XYZ axis, right? This is the origin of XYZ axis. This is the charge Q. Okay, this is the test charge Q naught. Q naught is the test charge is placed inside the region of Q. Fine. At a distance of r vector from the origin. The position is P, which is denoted as x, y, z. Fine. If F force is exerted by Q naught, if F vector force is exerted by Q naught due to the charge Q, then F vector will be how much? How much? 1 by 4 pi epsilon naught Q naught by r square. Okay. If this is the vector F vector, so we have to write the r cap. R cap is denoted the direction of the force. Fine. Fine. So where r cap is the unit vector in the direction of r vector. Fine. So we know the r cap is written as r vector by r. Therefore, F will be 1 by 4 pi epsilon naught Q naught by how much? R cube by R cube into R vector, right? So just put the R cap value into this. Okay, then we'll get this, right? Q naught by R cube into R vector. Okay, fine. Now let's divide the by Q naught in both sides. Fine. So F vector by Q naught 1 by 4 pi epsilon naught will be Q by R cube into R vector. Fine. Now see, this is F vector by Q naught is the force experienced per unit charge. Right? This is the force experienced per unit charge. F vector by Q naught, because the Q naught is the test charge, right? And this is equals to the electric field strength. Okay, and this will be equals to the, so this is the electric field strength. So we can write this as E. Okay, at the distance of r vector, so we put this r vector. Okay, so at the point, which point? At the point of P. Of P. Fine. Therefore, then what will be E? E is equals to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q by R cube to R vector. Fine. If we just consider the magnitude, then E will be equals to 1 by 4 pi epsilon naught Q by R cube. So this is the So this is the expression of what? Electric field due to a point charge. Electric field. Right? Fine. So this is not tough. This is the Q point charge. For this Q point charge, Q naught test charge is there, and the Q naught test charge will be experience the force of 1 by 4 pi epsilon naught Q by R cube. Fine. Fine. Now let's move to the another topic, which is electric field due to a uniformly charged ring. Okay. Electric field due to the uniformly charged ring. Okay. So let me draw first. So this is the ring of uniformly charged. Okay, this is the ring of uniformly charged, and we have to find the electric field due to the uniformly charged ring in what point? At a point, at the point of on its axis. Okay, at the point on its axis, any point at axis. Okay, let's say at this point, axis. This is the axis, and this is the point, and we have to find the electric field due to, in this point P. Fine, fine. So consider the positive charge Q distributed uniformly over the charge ring, and the radius of the ring is R. Suppose the radius of the ring is R. Radius of the ring is R, and the charge is Q. Q charge is distributed is uniformly distributed, right? In the ring, and radius is R. Fine. Then say the linear charge density of the ring will be the linear charge density, which means the charge density in unit spot. The linear charge density of the ring is equals to lambda. It is denoted by lambda is equals to how much? Q is the full charge by 2 pi r. 2 pi r is the circumference. Fine. Fine. Now, if we just consider a small portion, if we just consider the full portion dl. Okay. So consider a small element which is dl of the ring, and the charge of this element, charge of the small element dl will be how much? How much? Lambda into dl, right? Lambda is the linear charge density. Lambda is the charge at unit spot. Then charge at dl element will be lambda into dl, which is equals to dl into q by 2 pi r. Right, right. So we can just put it like lambda into dl. Okay. Okay, fine, fine. The electric field P due to this charge, in for this charge, the electric field at P will be how much? Now let me find it. So let us assume the distance from P to dl is a. Then the force, sorry, then the electric field at P due to this charge, which is lambda dl charge, okay, will be how much? dE will be 1 by 4 pi epsilon naught lambda dl by s square, right? This is the distance of A, so s square. Fine, fine. So we got the value of electric field of this portion, right? This portion, and now we have to find out the value of whole the ring. Then just what to do? Just do the what integration, right? Fine. So E will be the electric field due to the ring will be what? Integration of dE. Now see, this is the ring, this is the axis, and in this point we have to find the electric field. This is the dl portion, and the distance from dl is A, and this is the r, which is radius. And see, the this to this will be also fine. Now see, the limit of the integration will be how much? 0 to its perimeter, which is 2 pi r. Fine, fine. Now see, now see, d is the this is the d. Fine. And if we consider this, this will be also d. Now see, we have to find the electric field in this point, right? And here the d direction is this and this, so d will be split in two components, which is this one. For this d, this is the one component and this will be the other component, and for this d, this will be the one component and this will be the other component, right? Right. Now see, so this is theta. If we consider this is theta, huh? This is also will be theta and this will be also theta, right? So now just put the components, which will be equals to, see, this is dE, and this component will be how much? dE sin theta, and this component will be dE cos theta. Also for this d, this will be dE sin theta, and this will be dE cos theta. Now see, dE sin theta, d sin theta and d sin theta will be cancelled out because they are just one to opposite, right? So we only get the component of d cos theta. Okay, so we have to write d cos theta component. Fine, clear. Now see, 2 pi r. So the value of d is 1 by 4 pi epsilon naught lambda dl by s square. Lambda dl by s square. Now the value of cos theta. What is the value of cos theta? See, easy. In this triangle, this is 90 degree, this is theta, this is A. Fine. And the distance from its center to P is x. Now we have to find the distance from its axis at distance x from its from its center, right? This is x. So the cos theta will be from this triangle. Cos theta will be how much? Cos theta will be x by a, right? Base by is by hypotenuse. Fine. So we can write into x by a. The below cos theta is x by a. Fine. So equals to 1 by 4 pi epsilon naught lambda x by a cube. See. 1 by 4 pi epsilon 1 by 4 pi epsilon naught is constant. Lambda is also constant. Right. X is also constant. A is also constant. Just we have to do the integration for the term dl only. Right. So we put outside of the constant term from the integration and just do the integration of dl. Fine. So the integration of dl will be L epsilon naught lambda x by a cube. So the integration of dl will be L and the limit is 0 to 2 pi r. Fine. Now see 1 by 4 pi epsilon naught lambda x by a cube into now just put the limit 2 pi r minus 0. So 1 by 4 pi epsilon naught lambda x by a cube into 2 pi r. Fine. Fine. So see to cancel pi is cancel. So lambda r x by 2 epsilon naught a cube. Fine. So this is equals to lambda r by 2 epsilon naught into x by now see a is this. So a is written as a can be written as root under r square plus x square. Now this is the triangle. This is the triangle. This is a. This is r. This is x. This is 90 degree. So s square will be how much? R square plus x square. So we can write a is equals to root under r square plus s square. So root under r square plus x square whole power 3. So we can write lambda r by 2 epsilon naught x by r square plus x square whole power 3 by 2. Fine. So now just we prefer to write all these in the term of 1 by 4 pi epsilon naught. Right, 4 pi epsilon naught. So just we put the 1 by 4 pi epsilon naught. Okay. Then how much will be? So 4 means into 2. So there will be into 2. So lambda 2 lambda r x by r square plus x square and here we have to put the pi. If we do not want to write the lambda in this position, so the next expression will be 1 by 4 pi epsilon naught 2 into lambda is how much? Q by 2 pi r, right, into r x by r square plus x square. So this will be equals to E is equals to 1 by 4 by epsilon naught q x by r square plus x square, which is 3 by 2. So I think this is the more accurate expression. Right? Fine. Here just we put the lambda and In previous we saw lambda is equals to how much? Q by 2 pi. Just put it. Okay. Fine. Fine. Now the next topic is electric lines. Lines of force. So what is the electric lines of force? Electric lines of force is the imaginary straight or curved path along which the positive test charge is supposed to move when free to do so in the electric field. Like this is the electric field. This is the electric field. If we put a positive charge, if we put a positive charge, the positive charge will flow, will move in this way. This way. So this is the imaginary line, right? This is known as the electric field. Okay. So if there is the Q, if Q is the positive, if Q is the positive, then the electric field line will be displayed at this. Okay. This. And if the Q will be negative, then the electric field line is the as this. These all are the imaginary lines, and we find the presence of charge by this is the imaginary line. Right. So if we want to say the definition of electric lines of force will be the electric lines of force is the imaginary straight line or curved path along with a positive test charge, positive test charge is supposed to move when free to do so in an electric field. Okay. When it is free to move in the electric field, then the imaginary curve or straight line will be known as the electric line of force. Okay. Okay. Now, the interesting thing is two electric lines will never intersect to each other. Will never intersect to each other. Why? Say why? Means the reason is, see, this is the electric line, right? By this electric line, what we can say, by seeing this electric line, we can say that the direction of the charge is this, right? If we put the one positive charge and one negative charge, then the electric field line will be how much? The electric field line will be this. Right. In the inward direction towards the negative and the outerward direction towards the positive. If two electric field line intersect with each other, we'll see the two direction of the same charge. Right. In this point, there shows the two direction, which is not possible. How can it is possible, right? So this is the charge. This is the charge. And this charge is showing the two direction at a time. So this is not possible. So we can say that the electric field lines never intersect with each other. If any doubt occurs, feel free to comment. Thank you. Jai Hind.